These are the common questions about sucralose. What is sucralose? How is it made? And is it safe to consume daily? Sucralose is a chemical compound with molecular formulas C12, H19, Cl3 and O8, which known as an artificial sweetener used as a sugar substitute in food and drinks. Sucralose is classified as a modified disaccharide because it is chemically derived from sucrose. It is known for being sweeter than sugar with 0 calories. It has intense sweetness where it requires only small amounts of sucralose to sweeten the food or drinks. Since it contains 0 calories, it is safe for diabetics as it doesn't raise blood sugar levels. Sucralose has been considered safe as it was approved by WHO. However, the acceptable daily intake of sucralose is 5 mg per kilogram of body weight per day set by FDA and EFSA, as overconsumption may affect gut health. The main basic structure of sucralose was derived from a sucrose, which is a disaccharide composed of glucose and fructose linked by glycosidic bond. Sucralose retains the disaccharide backbone but undergoes chlorination where the hydroxyl group from carbon 4 of glucose, carbon 1 and carbon 6 from fructose were replaced by chlorine to give a 4-chloro-4-deoxy-alpha-degalactopyranose and 1,6-dichloro-1,6-dideoxy-beta-defructofuranose units linked by a glycosidic bond, an ether bond found on the glycosidic linkage which connects two structures. However, there are no ester bonds in sucralose due to the lack of carboxylic acid group. The chlorine atom in sucralose increases stability and sweetness of sucralose, while hydroxy group maintains its solubility.
Sucralose is synthesized by selectively chlorinating sucrose that replace 3 hydroxyl groups with chlorine atoms. Its raw material is sucrose, which is a disaccharide composed of glucose and fructose. The selective chlorination occurs as sucrose is dissolved in acetic anhydride, followed by addition of a chlorinating agent like thionyl chloride SOCl2. 3 hydroxyl groups are replaced by chlorine atoms at specific positions on the sucrose molecule. Now, let us moving on to the physical and chemical properties of the sucralose. Firstly, sucralose is said to appear as a white crystalline powder with no visible impurities. Secondly, it is highly soluble in water, moderately soluble in ethanol, and insoluble in nonpolar solvents such as hexane. Thirdly, it has an intense sweetness of 600 times sweeter than sucrose, which is why it is the most commonly used artificial sweetness worldwide. Moving on to the chemical properties of sucralose. Firstly, sucralose is resistant to acid or enzyme catalyzed hydrolysis, unlike sucrose, which breaks down under acid conditions. Next, it retains sweetness and structure under normal temperature, making it ideal for cooking and baking. Lastly, since sucralose does not enter the cellular energy cycle, it is neither broken down for energy nor absorbed into the body in significant quantities, thus contributing no calories.
Next, application of sucralose. In food and beverage industry, sucralose is used as sugar substitute. It is also can be found in low-calorie products, and it is good for baking and cooking. In pharmaceutical industry, sucralose is used as stable coating and also for liquid medicines. Next, in personal care products, sucralose can be used in toothpaste and mouthwash, also can be used in chewing gums. Last but not least, we are moving on to health implication of sucralose. What is the benefit of sucralose? The first benefit is weight management. Sucralose provides sweetness without calories, making it ideal for low-calorie diet. And then the second benefit is it is safe for diabetics. Sucralose does not affect blood glucose levels as it is not absorbed or metabolized by the body. Then for dental health, sucralose does not contribute to tooth decay or cavities. And lastly is heat stability. Sucralose is suitable for cooking and baking, unlike some other artificial sweeteners. What is the risk of sucralose? The first risk is gut microbiome disruption, which is it may alter gut bacteria composition and potentially impacting digestive health. And then the second risk is the possible metabolism effects, which is some studies suggest it may affect insulin sensitivity, though evidence is conclusive. And then moving on, it may contain chlorine concerns, which is the presence of chlorine atom may raise debates about long-term toxic effect, although regulatory agencies deem it is safe. And lastly, the last risk is digestive side effect, which is the high intake of sucralose may cause bloating, gas, or diarrhea in sensitive individuals.